Okay, guys, to solve this problem, what you have to realize is that the red car goes zooming down the hill, and when it reaches the bottom, it collides into the blue car. They join together and they go around the loop. So, from point A, which is the red car at the top of the hill, to point B, which is the red car at the bottom of the hill, so from point A to point B, energy is conserved. So the kinetic energy it has at point B, that's 1/2 mv squared, has got to equal the potential energy it had at point A. So that equation is true. Okay? Now, from point B to point C, energy is not conserved because there's a collision, but momentum is conserved. So from B to C, you can conserve momentum. So the momentum at B, right here, the red car before the crash, is equal to the momentum at C, which is the two of them after the crash, which I've labeled point C. So that gives you this expression here. The momentum at point B is the mass of the red times the velocity at B, and that's got to equal the mass of the red plus the mass of the blue times the velocity at point C. So you've got to solve those two to find the velocity at point C. Now, once you finish the collision, at point C, you have two cars moving, and they go up to the top of the loop, and I tell you the velocity at point D. So from point C to point D, energy is conserved again. So the energy at point C, which is kinetic, must equal the energy at point D, which is kinetic plus potential. So you're going to work this backwards. You're going to start with the height at point D, which you know, and the velocity at point D, which you know, and you're going to find the velocity at point C. Once you know the velocity at point C, you can find the velocity at point B of just the red car. And once you know the velocity at point B, you can work backwards and find the height of the hill at part A. Okay? So that's the strategy for solving this problem.